Hi everyone, exercise number 11 of the Demidovich book. They ask us to find the domain of a couple of functions. Function A, y equals square root of x plus 1. And function B, f of x equals cubic root of x plus 1. Here we go. These are the two functions that the exercise is asking us to locate the domain. We're going to solve A on the left side and B on the right side. And before moving forward, I want to clarify to everyone that I'm going to be using y equals f of x interchangeably. It doesn't matter. You can use either or. It's the same thing. Y equals f of x. So that's why we have y on the left side and f of x on the right side. So to solve, let's look at a table, domain of functions that we did on the previous video, remembering that we have to be aware of the restrictions. That is what we want to identify to solve the domain of the function. Here we have a radical, we have an even and an odd radical or root function. We have square root in case A and cubic root in case B. Case A, the inside of the root, the argument, is going to be where the restriction is. Therefore, in our resolution, we make a note that the inside of the root must be positive. It has to be greater or equal than 0. That is the restriction that we have for the domain. Anything that is not greater or equal than 0 is not going to be part of the domain of the function. We need to be a positive argument inside the root. So therefore, we make an additional note on our resolution that states that the argument or the inside of the root cannot be negative. Why? Because there are no square root of negative numbers in the real numbers. For example, square root of -2, that doesn't exist in the real numbers. Square root of -3 doesn't exist. Fourth root of -6 doesn't exist. In general, the even root of a negative number doesn't exist in the real numbers. So that's where our restriction is. Therefore, that's why we have to guarantee that the inside, in this case, x plus 1, is greater or equal than 0. Therefore, we have to solve this inequation. And this is a pretty simple one. All we have to do is just move the plus 1 to the other side of the equation. Our solution is going to be x greater or equal than -1. That is the solution to the argument or the inside of the root being greater or equal than 0. Therefore, the domain of the function is going to be the interval solution of the inequation, which is -1 close to positive infinite. And we can represent that graphically in our real numbers. That's it. So we put our square solution, and that is the domain of A, y equals square root of x plus 1. Now, for B, we have a cubic root. And what is the difference between an odd index in the root and an even number as an index in a root? Well, odd numbers such as cubic root, fifth root, seventh root, they have existence regardless if the argument, the inside, is negative or whatever. The inside can be anything, as a matter of fact. So that's why we can draw a happy face. Why? Well, because suppose that we had, for instance, -1 cube. That's -1 times -1 times -1, and that's -1. So if we were to do the cubic root of -1, that would be the inverse or the opposite operation. And that would bring me again -1 cubed. So there is existence if the argument of a odd root is a negative number. Therefore, there are no restrictions in these kinds of roots. Therefore, in general, the odd root of a negative number is going to be a negative number. And again, another example is cubic root of minus 8. Well, that's minus 2. Why? Because minus 2 times minus 2 times minus 2 is minus 8. Therefore, since there are no restrictions, the domain of this function is all the real numbers, from minus infinite to positive infinite. And that is our solution. We can represent it graphically like the whole line. And there we go. We make the square of it. So mind the difference between both types of roots.